This conference will now be recorded.
Hello students, very good evening. Today we are continuing with alternating current chapter. As usual, we are picking up various numerical problems from the previous JEE papers, JEE Mains paper. So let us read the questions one by one and try to solve them. Excuse me. So you see this problem here in the screen. The problem states that consider LR circuit. You see here LR circuit shown in the figure. If the switch S is closed at t is equal to 0, then the amount of charge that passes through the battery between t is equal to 0 and t is equal to L by R. So you have to find out the charge which flowing through this circuit between the time interval 0 and t is equal to L by R. I'll just mention the options given over here. The first option is given as 27 EL by R square. 27 EL. L is self-inductance, is the EMF of the battery. EL 27 EL by R. Sorry, this is R square. Then option B is EL by 2.7 R square. Option C is 7.3 EL by R square. This is R square. Or the option D is EL by 7.3 R square. These are the options. We have to solve it. So as you see, as soon as the switch is closed, there will be flowing of current, right? Since there is a battery of EMF E, and there will be, actually this is LR circuit, so current will grow in the circuit. So how it would grow? It follows exponential law. You can see that. So the current in the circuit I is equal to I0 whole into 1 minus e to the power R by L into T. Okay, T is the time, R has its usual identification R, so resistance. So now see what is the question. If the switch is closed, then what is the amount of charge passed between these time intervals? Okay, see, current means flow of charge, right? We can write dq dt is equal to I. Okay, this we can write, isn't it? So we can write 1 minus e to the power R by L into T, where this I0 is the maximum current in the circuit that can be obtained by this. Now look, we have to find out the charge, so we can integrate this. Okay, now if you want to calculate the total charge, so at t is equal to 0, charge over 0 as t is equal to 0. Sorry, t is equal to L by R. Sorry, yes, L by R. Let us take the maximum charge to be simply capital Q, and T is equal to here 0, here T is equal to L by R. Okay, so here look, this is a constant term, we can take that out. So this is I0. So here what we have to do, we have to do the integration part. So here I0 into T plus R by L into e to the power minus so this is the integration. So this will be L by R. L by R whole this is e to the power RT. Okay, after putting the limitations on T. So now we can just take the limit T is equal to 0 to. So if we just solve it and if we put this I0 is equal to E by R, then we'll be able to get that this is EL by E into R square. So this E is the exponential term, 2.7 R square. EL divided by 2.7 R square. So this is the charge. You can see in the figure here, option B, EL by 2.7 R square. So that is the answer for this question. What we have done nothing. We have just written down the growth of current or the equation of growing current in the inductor coil LR circuit. Then we have written that I to be equal to dq/dt, and then we have integrated over time. Okay, so this is how we have solved this problem. Now this question is again very interesting question and not very tough question. A transformer consisting of 300 turns in the primary coil. So number of turns in the primary coil we have got, and 150 turns in the secondary gives output of 2.2 kilowatt. So we know that actually in the transformer there is primary and then there will be secondary coil like this. Okay, primary, secondary. Let me draw it a little more decently. Okay, so a transformer, this is a symbolic diagram. A transformer, these are output terminals, these are input terminals anyway. So a transformer consisting of 300 turns in the primary coil. So a transformer consisting of 300 turns in primary and 100 turns in the secondary gives output of this much. So if the current in the circuit secondary coil is 10 ampere, then what is the input voltage and input current in the primary coil? Input voltage and input current you have to find out. So here let us write the option first. See the options first. So options are given as 45 amperes, I'm sorry, not this one. I'm sorry. This is something different. Just the options are 440 volt, 5 ampere. Then 220 volt, 20 ampere. This is 20 ampere. Option C is 220 10 volt. 220 volt and this is 10 ampere. And option 4 440 and 20. Four 40 and 20 ampere. So these are the options. You have to now find out the correct answer for this question. So to find out this question, you need to know about the transformer actions. I hope you remember this. There are number of turns, ratio of number of turns, and the current or voltage, etc. Those relationships can be used to solve this problem. So here I will be actually conveniently using subscript true for output voltage or current. So let us see, power is given, P2 is given as 2.2 kilowatt. Then number of turns in the secondary is given as 150. So N1 is turns in the primary coil. Okay, so these are the point given, and one more thing, secondary coil passes through current. The current through the secondary coil is 10 ampere. So this is the equations given. Now you have to find out the input voltage and input current. That means you have to find out I1 and V1. We know the power over here, we know the current over here, so we can find out easily. So we get P2 V2 P2 V2 is equal to the, sorry, I2 V2 is the power, that is equal to power. So we so V2 is equal to P2 by I2. So P2 is given as 2.2 kilowatt. I2 is given as 10 ampere. So this we will get actually, so there was 10, so 20, 220 volt. V2 will be obtained as 220 volt. Then we have to find out what is V1. So we know for output power, or we know the action of this so we know actually the N1 by V1 N1 by N2 is equal to V1 by V2. This relation we know. Anyway, this N1 and N2 are given. Can you find out uh, V1, because V2 is already given. So N1 by N2. So N1 is given as 300. N2 is, so N1 is 300, N2 is 150, and there will be V2 also, V2 220 volt. So it will become, actually see, V1 becomes 440. So this is actually 440 volt. So we have got the input voltage. Now input current. We know here for current, let me just erase this part. So another relationship we know, V1 by V2 is equal to I2 by I1. V1 by V2 means I2 by I1. So what is so V1 and V2 are known. I have to find out I1. I1 will be V1 by V2, V2 by sorry, V2 by V1. Okay, so or else let us just do reciprocal this part if you don't remember. So V2 and V1 they are known. I have to find out I1. So I1 I will keep here. So I2 is 10 ampere, V1 by V2. So problem number 36. Sorry, this 2. So I1 is actually 5 ampere. Okay. So problem we had to calculate V1 and we had to calculate V1 and I1. So V1 is the input primary voltage and I1 is the current in the output. Okay, sorry, I1, yes, input current and voltage that you have to calculate. So let us move on to the next. Question number 3. So now in this question, it said that an alternating current voltage alternating voltage where there is a voltage seen here and voltage applied to a purely resistive circuit of 50 ohm. The time taken for the current to rise in the half of the peak value. So alternating voltage is applied to apply certain voltage, so that is V of t is converted. This is the time varying field and a purely resistive circuit they are connected in circuit. Yeah, we have to find out the current when it reaches to the half of the peak value. Let us write the options first. The question is an alternating voltage V of t is equal to 22 of sine 100 by 3 volt applied to a purely resistive load. The time taken for the rise of the peak value of the peak value is 5 ampere. So first option is 5 ampere. So option A is 5 millisecond. To 2.2 millisecond. Option C is given as 7.2. 3.3 millisecond. Yes, so this is, sorry, the options are the 5 ampere, sorry, 5 millisecond. This is the time we require. Option B, 22. 7.2. 7.2 millisecond. So to solve this problem, we have to find out first the time period of this oscillation or oscillating voltage given. So what is the maximum value of the current? I max. So I max is equal to V by R. Now we have to find out the time period, you know, from the argument omega t. So we have actually, we have to find out the time period. Time period means 2 theta by So here 2 theta by omega, 2 theta was in this case. So 2 pi, keep as it is. This will be actually omega t. That means omega. This is omega. This is omega is 100 pi t. 50. So this is 150. Pi goes up. So this is 150 second is the time period, and you know any sinusoidal variation goes like this. So this is the maximum value Imax. This is the minimum value. So this is maximum. Now the current reaches the maximum value for a complete cycle. This is T by 4. So current reaches maximum value is given by. So if this take the whole time period, then the maximum value of the value of the half of the maximum comes here. This is the maximum, this is the half of the maximum. So if we want to solve this problem, then we have to actually see this is T by 4, this is the maximum, and this is again T by half, and this in between there will be half of, so this is the half of the maximum that will be half time T. So that time we have to find out. So this will be actually, see, the maximum current will be reaching at time so maximum reaches at maximum so this will be T by 4. That means so this will be 1 by 200 second 1 by 200 second for maximum current. Okay, so half of it actually, so instantaneous current so instantaneous time at which the current is half is I is equal to 120. When the current reaches its maximum, that is actually T by 4 that we have already calculated. If T, capital T is, okay, let me just make some spaces over here. Okay, let me, these are actually milliseconds. Let me, this is 2.2 millisecond. This is 3.3 millisecond. This is 7.2 millisecond. And the question is when half of the peak value will be there. Okay, so current, the time taken for the current ranging from half of all peak of the peak value is T by, here actually T by 4 is that is this much second. This is the maximum value, and if we go here, this is the half of the maximum value. So that is, this time we have to find out, and that time will be obtained from the expression itself. Let us say, so the maximum I max will happen 220. I will need new pages. Let me go here. We have been given the current is given as I0 sine 100 pi t, like this it is given. So if we want to make this as maximum by 2, this is anyway max, and let us say this is sine 100 pi some time t 2. So this will give half sine 100 pi t2. So this could be seen that this is 5 pi by 6 is equal to 5 pi by 6 is equal to this 100 pi t2. So pi goes off. This is 20. So t2 will be actually 1 over 120 second. That means this much second. So if you want to make it in the milli, so make it 1000 over here, 120. This is millisecond. So 120. Actually, the options were in terms of 3.2, 2.3, like that. So these options. So we have got T2, and that is the instantaneous. Okay, this is the time actually, and you have to actually find out. See this, during this time you have to find out actually time interval. So T1 minus T2. T1 was obtained as 200 and here 120. Okay, like let us write this T2 minus T1. So during this time interval that will be okay. So if we just take this difference, this will give you this much 1 over 300. And look, if you want to make milli, instead of making this as milli, let us not worry about here. So this is second, millisecond, and it is 3.3 millisecond. Okay, let me go to the question over here. So an alternating voltage were given like this, and it was actually given for purely resistive circuit having resistance 50 ohm and time taken for the current to rise from half of the peak value time taken for the current to rise from half of the peak value to the peak value. So what we have done, we have done that the time taken for reaching peak value, we have found out that that is T1, and C that was actually C time period, it's actually the time period by 4, that is T1 here, because it takes T by 4 times. So T was given as 50, T by 4 means T1, that is 200 second. So this is the time when it reaches to peak value, and let us take when it becomes half. Okay, half of the maximum value. So we have done here, it is, see when the time, see this is instantaneous values, half of the maximum values, and we can write like this, and from there we can find out that T2, the other time when it becomes half of the maximum of the peak value or maximum value, so that is 1, that time is 120 second, and difference between this, okay, that is called duration, and here that value is going to be 3.3 millisecond. Okay, now we'll quickly pick up the fourth problem. These are all actually from 2019 JEE paper. This also. Let us quickly read the problem. If a power transmission line feeds input power, so input power means V1 is given as, or let us say VP. VP means primary or input power in the transformer or transmission line anyway. So 2300 volt. A step down transformer with primary windings. Primary windings in one is given as 4000. Okay, so and the output power delivered at 230 volt by transformer. The output power is delivered to this. The question is the output power is delivered at 230 volt by the transformer. Okay. Now, if the current in the primary coil is given, that is IP is given as 5 ampere, and its efficiency is given. Efficiency eta is given 90%. Then what will be the output current? That means you have to find out Is. Okay. So we know efficiency means output power, output power divided by input power, okay, into 100. So we know this, the efficiency, output power means power in the secondary, and input power, that is the power in the primary. So we can write this output power to be VPIP, and this we can write as VSIS. Okay, now we have to find out what is the output current. That means IS, I have to find out IS is equal to eta into Vs divided by VPIP. You look here, IP is given 5 ampere, VP is given, VPIP, and Vs is also given. Vs is also given, that is the power delivered at this much voltage, it is said, and efficiency is given also. So 90 is the efficiency. Okay, 90 is the efficiency, and the Vs is 230 volt. VPIP, that is the input power, that was given as this much. So this goes okay. So and there was okay. So there would be 100 also here. Excuse me. So IP, VP, IP was given. VP was like this much voltage. IP I have not mentioned here. Okay, so this is IP. Okay, so VP IP, and here 100 also has to be there. 100 also will be there. Okay, I think this space is too congested, that's why calculation error is coming. Let me just write in the left hand side, or maybe I'll go to the next page somewhere. Actually, eta is VSIS, output by input volt power. Okay, VPIP. Okay, this into 100. This will give you the percentage. So here it is already 90% given. Okay, so VS is given as 230. If you see 230, IS we have to find out output current. Input voltage is given as this, and IP is given as 5. So along with this 100 will be there multiplied. So this 2, let me strike this, let this be 10, this be 2. So IS will be actually 90. So this percentage from both sides will be going off this. So this is in ampere. So this is IS. So 45 ampere will be the current in the output. Output current will be 45. Actually, the options were given as 45 ampere. Options were 45 ampere. Second option was 50 ampere. Third option was 25 ampere, and fourth was given as 35 ampere. So we have got here, this is okay. So this is 90, and VP here VSI, VSIS, VPIP. So we have already calculated what will be the answer. The 45 ampere will be the answer. So we'll stop it here for today. We'll take up. Actually, there are many more questions on this AC part. We will have at least one more slots or one more session on this alternating current, and then we'll move on to the other chapter. So thank you for your patience. Bye for today.